Basic insulation. So what we've got is we've got the pit coming in here. What we need to do is we've got a few tests that we need to go through. The first one mostly we do is doing the earthing system first. We have our main earth, we have our water pipe, which is our bonding conductor. They come back here to the earth bar, all right? We have our MEN link, which we're going to put in, okay? Now, what we have is we have a main switch stove. The stove's now going to be an RCD, okay? This one's a circuit breaker, but we will be changing. We have two RCDs protecting power and one protecting the light. So our lighting circuit is the fan with the light switches here. Then we have four power sockets, two on each RCD. Then we have the stove down here with the appliance and our earth point. That's our first one here. So this is treated as a separate appliance, okay? So when we're doing measuring today, I want you to measure between the earth and the earth point here to make sure it's got continuity first. And then what you do is you'll do an insulation test between here and the earth pin, or between here and the earth itself. Make sure that the stove's turned on. There's no use measuring something if it's turned in the off position. All elements have to be turned on. Okay, so that's our stove. Here we have a simple sweep fan or exhaust fan. This being the metal part of the frame, so we need to go from here to the earth pin and then make sure that the fan's turned on, and we do an insulation resistance test. Same as what I was talking about here, insulation resistance test to make sure it's not down the ground. These have to be removed when you're doing the circuit tests for the circuits, because this can create a fault on itself. So make sure it's unplugged and the switches are in the on position. So the first test we're going to do, right, is we're going to test the earthing conductor. We're going to use a thing called the insulation resistance test. It can't be called a Mega because that's a brand name. So when we have a look at this, the blue scale is what we're going to do in ohms. The red scale is what we're going to do in insulation resistance test. You'll notice we have 3 and 5. The first thing I need to do is do a battery check. Battery check's important, all right? I'll make sure my button's released. So what I do is shorten my meter leads together, do a battery test. Okay, that's telling me the battery's okay, it's in a good position, all right? And then what I'll do is check my ohmage. It's sitting on 0, so zoom in for ohms. We've got 0 there, sitting on 0, perfect. The other one then we do is we go to 500 volts, and it goes back to nearly to ohms on that side there, all right? So it reads two different ways. 0 reads down here on the left, down towards this way, and 0 reads on the opposite side. The difference with the red scale is that we're pumping 500 volts into 240 volt circuit, which is what this is. If we were doing a 3-phase circuit, we would do 1000 volts. Okay. Remember, it's a DC. This is DC, not AC that we're putting in. We're putting DC in, so it has to be double the voltage. Okay. And DC will pick up faults a lot more than AC. What's the problem with AC?
Alternates?
Yeah, it's kind of moving up and down, it's going strong and broke. DC is basically full strength all the time, all right? It's going to put a charge or a demand on the circuits all the time. It's not going to be moving up and down, all right? Like the AC sine wave. Anyway, the first thing we need to do, if you're checking under verification in the rule book, it has all about visual faults, and then it starts like there's a little flow diagram there. The main thing you need to check is make sure the installation part is that the main earth is working to the earth bar, all right? Then we check the bonding conductors, and then we go through to check all the, what we call protected earths, which are the ones that run out with an active and neutral to each power point. And then your bonding conductor doesn't have an active and neutral running out with it, all right? So these are what we call protected earths, or protective earths, which means is if we get a fault between active or neutral, the earth will give us a return path of current. So what I'm going to do, what's my maximum resistance? So what I'm going to do is now select it to ohms, 3 ohms, all right? The rule book says it shouldn't be more than 0.05, okay? We don't want a high resistance, because if we've got that, we've got a problem. One thing you need to be careful of is don't do it from here to the clip. So if I go from the earth bar, I'm going to put my MEN link out as well. If you go from here on the earth bar, don't do it to the clip, because there could be a high resistance under the earth stake. Do you understand what I'm getting at? It needs to go to the earth stake, which is sitting on top here. All right. So I'm getting a resistance of just over 1.5, which is a fail. It's more than 0.5, so that's telling me it's a difference. And if I go here, it's about the same. Sometimes you'd be surprised when you go from the pipe to the clamp how much the resistance could change. All right, because there could be a high resistance. All right. Okay, so that tells me that fails. That means to be adjusted or looked at. If we have a strip earth, that's the reason I'm going to talk about a strip earth now, is you won't have this tag on here and you won't have the clamp. A strip earth will come out of the board, run down straight in the ground, and that's it. And that's about 25 mil square. So it's pretty hard to do a test or what we call continuity test on a strip earth because it's a set length and it doesn't have any joins in it. Okay. The reason we do this test is because we've got this join here that can give us a high resistance. All right. Bonding clamp's the same. We have the same resistance, so I'm going to go from between the earth bar to my bonding clamp or my piece of water pipe, and the same thing. It's over 1.5, so it's failing. All right. So at the moment, I'm not having a good run, but as this board's a fault board, it's got faults in it. The water pipe and the main earth are failed. All right. So we've done that test. The next test I do after that is to check all my sub-earths. So I'll go from the power point here, that's telling me it's got 2, and I work my way down to all my earths, all right, making sure. So these are not doing too well at the moment because they're all very high readings. This one hasn't even moved, so that tells me that the earth's not even hooked up to that one. We come to here, this is reading down to 1. Back of the batten holder, there's a little brass clip that sits in the back between the 2 pins. That's where I want you to test to make sure the earth there. So at the moment, I'm testing between the main earth bar and the back clip, and there's nothing reading there. So that tells me that the earth is not hooked up. So there's no earth continuity there. All right, go into my stove, and I've got continuity there. A bit of a high resistance, but I'm still showing continuity. So now I've done all my earths. All right, done the checks and done what I need to check, if they fail or not. But some of them are not even showing continuity. So the next thing I'm going to do is we're going to do the whole installation. We need to make sure that all circuit breakers are in the on position. The MEN is disconnected. Okay, all right. This the link has to be put through. So my mains are going to be separated, but the problem is I've got to put a link over here. The reason I have to join this is why.
The meter's not connected.
Exactly. So this is where my meter. The reason the neutral's small on the meter is it's only got to read the voltage potential. It doesn't have current passing through it. The neutral will come from here to this link bar. All right. When it goes from the link bar, it goes straight to the neutral bar. The problem with the active comes to here, goes through the meter, and then back through the fuse, back to, the main switch. We don't have to disconnect or do anything on the neutral bar here, but the active we have to put a short between. So what we're going to do now is we're testing between the actives, right, the neutral. The neutral's been disconnected now because we don't have it at the same potential as the earth because the MEN has now been removed. So the idea is to make sure that the insulation resistance between the active and neutral to earth is more than 1 mega ohm. So what I'm going to do now is we're going to put that on to 500 volts, which we've got. Test my meter to make sure it reads down to 0, which it's doing. Okay, now what we'll do is I'll go from the top of the main switch to the earth bar. Now that should be taking in my mains back to here, and it should be doing, so I've got between the active there. Now I'm going to test between the neutral as well, between earth and neutral. So I've still got a high resistance, and the same with active to earth. Now see, the active came down to a low value. Now some people, I tend to test the active and neutral separately so that if there's a fault you can identify. But what some people will do is they will put a bridge between here. So if you want to do the whole insulation active and neutral at the same time, I'll put a bridge between active. It's a slippery little shit. Right, so I've bridged the active and neutral together. Now watch, if I do that between earth and the neutral now, I'll get a low reading. So now it's down to 0.5, which is a fail, okay? and that means it's failed. So now what I do is if I break that off and go between active, I've got to fail down to 0.5, which is a fail. I need 1 megohm minimum. All right. So another way you can do, as I see as a quick check, is you can start turning off circuits. And if the meter creeps up, that means you're eliminating the fault. So it only works more on RCDs because you're actually taking the active and neutral out of circuit. But we have identified that if I go between earth and neutral, it's actually all right. It's reading a high resistance. It's more than 1 megohm. So my fault is in the active conductor. So if I take out the lighting circuit, it's now brought it up to 1 megohm. If I turned off the power circuit, it didn't change it much. If I turn off the next one, it's brought it right up, so it's removed it. So I seem to have a problem on the power circuit and probably one on the lighting. But if I bring the lighting back in, it actually brings it back to 1 megohm, but it could be a slight problem in there. When I did the second one and brought that one back in, it doesn't change it much at all. But when I do the power, it actually brings it back down. All right, so the other one I can do, the stove doesn't make any difference. Okay, to change this one, it brings it up a little bit, the power circuit. Same with those. I think I would put my money back on the lighting circuit. So what we'll do now, so if you do find a fault on the mains, the next step you normally do is you would go in and test each sub-circuit. Do you understand what I'm getting at? So you would turn all these off, you'd go between earth, and you start looking and turning on, leave it turned off and test between the active and neutral and pick up each sub-circuit. So this one to here is giving me more than 1 megohm, that's okay. I'll then test the next one, more than 1 megohm. Come in here, test the active conductor, and just below 1 megohm, all right? So we've got a fault and we work our way along the circuits. When we do insulation resistance test of a appliance, what we will do is make sure this is turned on into the on position. The first thing I want to do is go back and check my earth. So what I'll do is I'll set it back to 3 ohms. Make sure I've got continuity between here and my earth pin. All right. So what's that telling me if I've got that there and nothing shorting between? What's that? Have I got an open circuit? So there's no continuity. When I short the leads together, they go back to 0. All right. So we'll just readjust that again, sorry. But I'm getting no continuity. So this could be a built-in fault. I've only picked a random board. So that's not quite going down. So I've got a high resistance on my earth there. So there's no real continuity of my earth. It should be going back to 0. All right, something simple. All right. The next thing I will do is go to 500 volts, test between earth. And what am I getting? It should be coming back up. But I've got a high resistance there. So it means the insulation resistance is okay. I'm also going to check to the earth pin as well, and I still have a high resistance. So there's no short on that at the moment. The problem I've got, I did identify, is between the earth pin of the frame and the earth pin of the plug on the frame. There is a high resistance there. All right, it's down a bit, but not low enough. When we come to this one, same one, test between the frame and the earth. So what I'll do is I'll go to 3 ohms. Okay, so now notice that one, pretty much coming back to 0. That tells me my earth is all okay. And then what I'll do is I'll go back to 500 volts again, and we go between the earth pin and the active, and I have a very high insulation value there as well, somewhere around about 5 meg. Everything you do on appliances and the main insulation has to be above 1 megohm minimum. All right, if it's less than 1 meg, it fails. Okay. All right, and what did we say between single phase and 3 phase? 500 volts on single phase, 1000 on 415. All right, so you're doing a 3 phase motor, you've got to remember it's got to be on 1000 volts. All right, so as I said, there's other tests. The other test we've got to do is check the continuity of the mains. So for me, we leave this pushed into here and check the polarity. So I'm going to go between the main switch and I'll go between here. So I've got continuity on here, and then what I do is I go between the neutral bar and there. So active is active, neutral is neutral. All right. RCD test, we also go through to make sure the actives are switching to the active conductor. So what I'm going to do is we're going to pick this one here, it's turned off, and make sure the active conductor, so that tells me that that's in the correct pole. So that first one there, I'll do the second one, the switch is turning on and off. So that identifies that the active is switching in the correct position. Alright, if I come down to this one and pick up the active here, it's still doing it. Okay, let's try the fourth one. Alright, so that tells me that these two here are switching to this RCD okay. These two here are switching to this RCD here. So they're all working correctly. Alright, I want you to have a go on the board here. There's the list of all tests that we do are in the rule book. There's 5 of them, or 6, sorry, more tests as you work through them. And if you've got any problems, give me a yell.